Okay, we have here particles, 4 particles with their charges, and I wrote them here. So, and we need x and y component of the net electric force on particle 2. So we need net force on this particle here. Someone, my student that I worked for 4 years ago, with this assignment for, he gets some result, but this result was not good for him. So I was doing this for him. So what is the problem here? It's not too difficult, but there is a lot of calculations. So forces drawing not in scale, of course. First of all, you see what kind of charges they are, where they are, and so on. So we need the force that is exerted on this charge, and we have 3 additional charges on these points in this, how do you call this, point at the end of the square. Well, okay, this is the 104 nanocoulombs is here charge of this one, and charge of this one is 266. This one is the same but is negative, and this one is same 104 but is negative also. So first of all, when you do this kind of assignment, you need to find, is there attractive or repellent? Is this force attractive or not? So these 2 charges, Q1 and Q3, repel each other. Why? Because they are both positive. So force from this charge on this charge will be directly downwards. So as I noted here. And force on this charge from this will be attractive. Why? Because this force is negative and this is positive. So this will go in this direction, and this will go in that direction. This is 45 direction. Why? Because they are all sides are the same and so on. But it will not go downwards, it will go upwards. Why? Because they are opposite charges. So this is negative and this one is positive. That is important when you add or subtract. So this is the x direction, this is y, and so on and so forth. So this is the how you calculate the electric force between 2 charges. And first is the easiest one to calculate force exerted on the third charge by the first one. 1 nanocoulomb is x 10 to the minus 9. So why the minus sign here? F13. F13 is, as I say, this force from this charge that is exerted. Now that's why did I place minus? Well, because y is upward positive and this is directed downwards. So that is negative in respect to the y-axis. And that's why when I calculate, I will place here minus sign. So minus sign, this is the Coulomb constant, this is the distance between the charges, these are the charges. So one piece of the force that is exerted on this, we already calculated, and that is this much. And that is in y direction. This negative y direction. This now I calculate the force exerted on the third charge by the fourth one, and that will be positive. Why? Because as you see, this force is directed in same in same direction as the x-axis. So that will be positive in respect to that axis. So that's why there is no minus sign here. Just leave it as is, or plus, put plus if you want. So when I exchange all of this, and then I get x component that belongs from that originates from the charge number 4. Now, when you calculate force on this, is not too difficult to calculate what force is, but when you calculate the magnitude of the force, then you need to project that force part of the x-axis, part of the y-axis, and then you add all together with x-axis, and you add all together with y forces that are projected on the y-axis, and that's all there is to it. So you could try and do it yourself to the end, or for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.